Slide text. 10th Anniversary IT Professionals Conference. The Wisconsin University seal lies over an image of people seated at event tables. Please note we were having technical difficulties with the room's sound during the session.
We are very excited to present Professor Patrick McDaniel to us for our keynote today.
Headshot.
Patrick McDaniel earned his PhD at the University of Michigan. He did a fellowship at NASA, then did research at Bell Labs, and was a professor at Penn State for 18 years. He worked in startups in the early to mid 1990s and saw that security was going to be a big deal once the internet really blew up. Seemed like some good foresight there. And this understanding guided his path from there. He works to understand security and privacy issues and how to build practical systems that users can use to achieve both. His work embodies the Wisconsin idea, and we are very excited to have him here with us today. Everybody, Professor Patrick McDaniel.
AI opportunities, challenges, misconceptions, and impacts.
2016. I was sort of the tail end of a bunch of research, was lucky enough to be one of the first people to have access to this operating system for computer that was going to change the world. It's called Android. And I spent about 10 years doing research on the security of smartphone systems. And 4 months in, Google invited me out to Palo Alto. And there was about 10 people in the room. And we were sitting there, and what Google does is they'll get a collection of people, they'll bring them to our Mountain Dew. And sit in Mountain Dew, and then they roll out the stuff. You know, everything's Google is rolling out, and they basically say, what do you think? And I heard stuff because in that moment, I was sitting in this room, and then they brought up a photograph. And that photograph said, okay, now we're going to ask this bot, what is in this photograph? And it said, this is a white Dalmatian, white-black Dalmatian on a green field, and the grass is long. Now, this is 2016. This is the stuff of science fiction at the time. And we looked at each other in the room, and it was really the astonishing first moment where I realized that AI had finally arrived. And moreover, I leaned to the guy to my right, who just happened to be from the University of Wisconsin. And he's so much job, was also a professor of computer science history. And I said, well, he said to me actually first, this looks like magic. And I said, if it looks like magic, then it's vulnerable. And that controls system on more. We just have to sort of ask that technology. We have to figure out what are the challenges of any technology. And so I want to get something done over the next 15 to 60 minutes. I want to start building a mental model. So my background was really in IT. I started out my earliest days in technology and startups doing network management, and really lived in that. And through that experience, I've always been able to I've always made an effort to really look at how these systems are going to be maintained and how those systems and new technologies will affect how we carry out the things we do every day. And the things we do every day does not happen without the people in this room. This is what I want to do is I want to help start discussing what are those things we should be thinking about when we think about AI. So Elizabeth Day has written that AI is transformative. You've heard it. Listen, if you don't know it yet, just go to YouTube, look up robots. It will be transformed, right? And it will have tremendous benefits. It was just in a discussion with people about the outcomes for the age. The number one killer of the elderly is loneliness and isolation. After it turns out chatbots, just talking to OpenAI's ChatGPT and developing a rapport actually massively improves the outcome of the elder.
6 industries.
And it'll be multidimensional. The environment will know this person. They will know when they're in crisis or when they're having a medical moment. And it will not require full-time, very expensive human beings to monitor the health. AI will change lives. We're going to see this in healthcare. When AI came out, we all got 1 to 2 extra decades of our lives. because of personalized medicine and all the other things that medicine will bring over the next few years. Education, well, we're still trying to figure that out. We'll talk about that a little bit later. Scientific discovery, etc. So let's just take that as written, that it's going to be massive social benefit. But I really want to focus on how we want to think about it. And to start, I want to think about an experience I had. I was in Germany with my family, and we were in a rental Volvo, and I was driving. We were east towards the Polish border, and this set of trucks drove by. This is probably 2019. And the first truck has a driver in the front, and all of the rest of the trucks have drivers, but they're not touching anything. And the trucks behind them are about 2 feet behind. And there's about 5 of these trucks.
Truck photo.
And I thought, wow, that's super dangerous. But actually what was happening is that was the first generation of deployed autonomous vehicles. It's called platooning. So the front truck was actually a human driver, which is the hard part for navigation. The remaining trucks, all they had to do was follow the front truck. And so the process, the thing the AI was doing at that time was significantly simpler than autonomous vehicle does today. Now I bring this up because in that moment I thought to myself, wow, I came from the 8th forest county in the United States. I was from coal country, a little county called Athens. It's right across from West Virginia on the Ohio, the southeast side. It's basically West Virginia. And it doesn't have any natural, it doesn't have any industry itself. And so in that space, what drives the economy is basically flyover traffic. Basically, trucks come in, the large depots, we have a few warehouses. Walmart, of course, has a big warehouse in this county. And a lot of the money is driven through that exchange. This the movement of goods across the country they have to divert. And because our county is so large, it's really cheap to do things in that county. But I go back to Germany and I'm asking myself, okay, so now if this is 2019 and 2029, and all of those trucks don't even need humans, because we kind of saw that arc coming. What happens to them at this county? So the humans aren't going through. Fueling isn't going to happen. The restaurants and hotels support that way to do those things. And probably because there isn't going to be any limitations on the hours that a driver can drive, which is the biggest limitation of trucking.
Approximately 14% of jobs at risk.
The economy will collapse. I'm going to come back to this because it sounds like boom, and it kind of is, but there's a much broader result that we're going to get here. Now, multiply that. How many people do you think are in the trucking industry in the United States?
Text lists industries.
Give me now. So, okay, here we go. All right, I love the end. 2.5 million to 3.5 million, depending on how you want to count them. So, something like 1 out of 100. So what if in that industry we have a reduction of 8% in that environment? Well, it turns out that could be disastrous. The assumption is that nothing changes. I'll come back to that.
Text. Brief loss of audio. What is AI?
I want to start by building this framework. I said I want to get something done. I want to start by building a framework to understand. So AI is a thing. It's an algorithm, it's a model. Essentially, you take a big bunch of data, you do some complex math, which is largely what's called an optimization, and you get something that's a model, right? And the model is for some phenomenon. So an example we would see in something like an autonomous vehicle is you would have a set of things called signs that you see on the road, and this autonomous vehicle has what's called a sign identification subroutine of its larger system. And so what happens is this autonomous vehicle will take pictures of the environment as it's driving down the street, and it will then transmit those to this particular computational unit inside the car. Unless the car part of it, here or there. But what it's going to do is that it's going to take that and it's going to feed it into the AI. And the AI is going to use examples of all the signs it's ever seen and it's going to say that this is a stop sign, right? In this case, like a stop sign there, it says, hey, this is a stop sign. Now, what's important is this is called statistical machine learning, right? And all AI is statistically based. So the way to think about statistically based is sometimes wrong, right? And so therein lies the trapdoor of AI.
Car diagram.
It will always be wrong sometimes. And so when we are deploying and using AI, we have to be very conscious of this. And this is where we're gonna find we class the hype curve.
Model diagram.
Now, if you extend these models, you get things like GANs, generative adversarial networks, and they're basically you take a couple models, and what they do is they generate things that are like the distribution, like the phenomenon that you trained AI to do, but not from that set of samples. And let me give you some examples of this. All right, does anybody recognize these three people?
3 people photos.
They look familiar. Well, they're not. These people did not exist. Please go to thispersondoesnotexist.com. It's actually a website. It's actually NVIDIA that's behind it. You can set demographics, and you can set whatever you want. It's free service, it's kind of fun. And also sort of frightening at the same time. And you can create a human being. It looks absolutely real. Same thing with any kind of text. For example, this is actually kind of an older paper from the University of Chicago where they did restaurant reviews and they were creating fake restaurant reviews. Anybody who's down Yelp would know what a fake restaurant review is. But it said that it's 2020. It said, I had a grilled veggie burger with fries. Ooh, and oh my God, very flavorful. It was so delicious that I didn't spell. Sounds like my undergrads.
3 reviews lie beside the photos.
But now, we're in this weird space as a species. Right? Wait a minute, objective reality. What's real and what isn't, and it's kind of up for grabs. And that is changing our inability to cope with that. It's changing things like political discourse. And, promoted by things like social media. I'll come to that a little bit later.
Large language model graphic.
Now, 2016, 2017, 2018, 2019, 2020, 21, 22, we started to see ChatGPT. And now, all of these toys, or these very narrow uses for AI, suddenly kind of exploded. Everybody remember that first time you sat down with ChatGPT and then, excuse the expression, said, oh, yeah. Right? And every generation after that, we got a little bit more disturbing, also really utilitarian, and then writing undergrad, advising letter again. But these are really just taking the same technology and making them big, right? So these are basically neural networks, and there's drags and transformers and a whole bunch of other stuff that they use to sort of amplify. But it basically boils down to it's really just the same stuff made bigger. Now, this is really weird. What's interesting about where AI came from. What enabled the AI revolution was a game called Doom. Everybody remember Doom? Right? So Doom was, and the consoles that went after them were incredibly profitable. And there were generations of these. And then basically every, not to be sexist, but every boy that I know above the age of 13 was playing some games at some point, and a lot of women as well. It became part of the zeitgeist. Games were everywhere. Today, the gaming industry dwarfs by like 2 orders of magnitude the movie industry. But where it describes AI is that it drove GPUs. It drove the generation. People wanted more and more and more realistic graphics. They wanted faster. They wanted better resolution. They wanted bigger monitors. It drove that. And at the same time, we were in what was called the AI desert. AI was basically dead as a discipline. And they said, oh, don't do AI because instead it's never going to happen. But then that GPUs were able to process the complex computations of things like neural networks through GPU pipelines. So the very thing that made graphics and things like ray tracing possible were exactly the same thing that made AI possible. And so at that point, as these GPUs advanced, AI became more and more feasible. And when we hit the inflection point where the GPUs reached a level of capability that could support the kinds of applications we see today, the whole game changed. NVIDIA is the most valuable company on the planet. If you bought just a few $1,000s 5-6 years ago, NVIDIA would be a multi-millionaire. The moment was there. And so, as we begin to understand the space of AI, we really have to think about that evolution. And then it evolves and evolves and evolves. Kinds of models. And this is a little bit of simplification, but again, we're trying to build a mental model for how AI works. There are small and edge models. Those of you, I run Llama on my desktop. It does pretty much everything I need to do, plus or minus. And these are small and edge, and they have something like 10 billion parameters. So understand, 10 billion parameters sounds like a lot. 5 years ago, we stood that in hardware to reasonably run it. I can run it on my M4 or M4 purpose, right now. Okay, so those are smaller edge. They're medium and open weights. These are larger models that you're likely to encounter in this university where people are running their own models on campus. These are things like if you're doing something like modeling solar wind, or you're doing some deep computation or something like that. Whatever area you're in, you're probably, those are the models. And open weights are really just another way of talking about things that are openly available. And I'll come to that a little bit later. And large and frontier models, these are the big ones. These are the models that are just, ChatGPT and Anthropic and et cetera, et cetera, et cetera. Those massive models are the ones that you will see you buy tokens for.
Text. How fragile is AI?
So how fragile is it?
How many people went to kindergarten?
Two blurry stop sign photos lie side by side.
A little frightening. Okay. What's the thing on the left? The stop sign. What's the thing on the right? No! It's the yield sign. So this is actually a paper that just one of the first to pass on AI. This is stuff from the University of Wisconsin, and our group has been pioneering for 100 years. Essentially, what's happening on the right-hand side, this is called an adversarial sample. And I'll talk about a little bit how they get created in a moment. But essentially what it is a sample that has been modified in such a way to make AI think it's something that's not. And here's the trick. Here's the thing to know, is that if you know something about the AI, then you can give it something to give exactly the output you want. Right? So, and then the way to look at it, when we think about that, is in an adversarial setting, the adversary can induce the model. If they know a lot about the model, they can induce any behavior they want. So now as we begin to think about putting AI in critical applications where there may be an adversary present, we need to take a beat and think about that.
An annotated email appears next to a photo of a crashed Tesla.
Adversarial samples are not new. Right? So this is the stuff computation from old. Basically, this is a well-known computational problem that is finding the worst-case output for worst-case input for an algorithm. Right? And I don't want to get into computational theory, but think of it this way. How many people are working in some level of security? You probably all are in some place or not, right? Okay, so we all know we're looking for things like phishing, right? So when I was at Bell Labs, one of the things that happened is, and this is basically in the early 2000s, in Bell Labs, they came to us.
Text. Short break in the recording due to technical difficulties. We apologize for the missing content. Text over the slide says, adversarial samples are an example of a very old problem in computer science and security. Finding an algorithm/system input that induces worst-case behavior. The next slide says, attacking AI. Jacobian-based saliency map approach, JSMA. A diagram fills the slide.
So, two things down, it's always possible. It's not a vulnerability in the model. It's the fact that a model, this big mathematical thing, is a complete compression of the phenomenon you're actually modeling. So in that compression of that entire phenomenon, there will always be spaces where the model is wrong. Because you cannot have a complete representation of anything. There is no complete set of all possible road signs anywhere. You could always produce a new sign in a new lighting environment, but that, put moisture in the air, who knows, right? There's always things you don't know. And as soon as there is, that's called a vulnerable space. As soon as you have a vulnerable space, all you have to do is take some input and turn it into a malicious output. This is actually from the end of the data set work we did, and we showed that for like check reading, banks use check readers to see. Basically, we can turn any number into any other number and we just make up whatever the account should withdraw. And so we can just redo the checks to give ourselves arbitrary amounts of money. That they were super happy about that.
3 diagrams represent models.
Now, this is not a function of vision, because I showed you some examples of vision, but it doesn't really matter. This is a function of math. Any approximation has error. Full stop. All AI is approximation. Full stop. So any kind of AI will have this. And any kind of area that you're working with, text, vision, or sound waves, or electrical currents, doesn't matter. It's always there. And so, as a practical reality, you have to design systems. And as you are going to get enormous pressure in the IT community to deploy systems, you have to always be asking yourself, what would the adversary do if they had access to this thing?
Malware versus benign diagram.
And the economics are strong, and so the pressure is sometimes not going to be pleasant.
Accuracy graphs.
Now, there's another misconception I think people have about AI. Number one is models aren't actually learning or thinking.
Text your photos.
Okay, so we should just excise that from our vocabulary. That is my mission in life, which I will ultimately fail at. Because it's too easy to metaphor, right? But it's not actually learning. It's learning a mathematical approximation of a phenomenon. And we did some work here, this has just come out in the last 6 months, which has really shown that vision systems aren't actually learning what a dog is. They're learning what is the relative textures in a vision system. Right? So this is called an alligator plot. What it says is that if the model matches the dominant texture for a particular thing that we're identifying, for example, baby bibs have polka dots. Don't know why. That's what they do. If a baby bib has polka dots, AI is very accurate. If a dog has, visible fur, very accurate. But if you start having phenomena that don't have those dominant textures, then the vision system is actually wrong. And we see this in what are called natural adversarial samples. There are things out there in the universe that vision systems in particular get wrong. For example, if you put a net down and you put a key on it, and you say, what is that? It will say something like a net or a brick. Because the dominance of the texture, we have something called focus. Our brain, because of our evolutionary progress, it filters out the net, because we know we're looking at a key. AI doesn't do that. We can try to emulate that, but then it requires the kind of reasoning we're just not good at that. So where does this, and this is again, just not vision. All AI systems aren't actually learning. They're learning correlations between particular features or collections of features and the phenomenon we're actually modeling. And so this is really important for understanding vulnerability, but also in the applicability.
Sword fight illustration.
Not a security guy. My background is actually in cybersecurity. We don't really have a definition of what secure AI would be. My collaborator, the guy who actually invented hands, a guy named Ian Goodfellow, He and I wrote a bunch of papers together. He's now head of AI for Apple. He produced this paper, I think it was 2014, and started thinking about what AI, what potential definitions would be. And there's these things called norms, and they're actually sort of mathematically derived, but they don't actually measure security. And the problem is that there is no one definition that actually works. And so we in the security community, research community, don't actually know what security is. I just went out to anybody know of RSAC, this conference out, the security conference out in San Francisco. I was just out there about a month and a half ago. And it's, if you don't know, it's a big industrial conference. There's about 30,000 people. It's all the whole security community. We're all standing there and going, booth, booth, booth. And they're telling me, if you run our software, your AI is secure. And I'm like, okay, what does that actually mean? What's the guarantee? And I never got straight. People are so desperate. This is the, you guys that know the green light phenomenon. Right? If you give me a green light, it tells me all is good, whether that means anything or not, I'm happy, right? That's every vendor that you've ever worked with. As long as the light is green, you're good. Don't worry about the details. And unfortunately, we don't even at the research community have a good definition of what that actually means.
The devil emoji sits between two model diagrams.
Another thing to know is AI is not a secret. So if I can talk to AI, if I can talk to them, it tells me a little something about itself. It tells me a little something about the data that was used to train it. So we have sensitive data. This the sort of canonical example of this is actually in the medical field, where if your personal patient data is being fed to a model, can someone who's talking that model later learn things about you that you don't actually want public? And the answer is yeah. It's called membership attacks. They can figure out if you're in the data, they can figure out things about your data, and there's a whole spate of approaches to actually do this. This is a whole subfield. But that's a secondary problem, and this is called transferability. So this is another paper that we did here. This was the first one we call black box attack against AI. And what it really does is I talk to a model for a little while, and I sort of map it a little bit, and then I create what's called a surrogate model. And that surrogate model is actually pretty good approximation of the original model. So what that means is if I can talk to your AI, I can replicate it. And if I can replicate it, I can attack it. I was actually spending some time with high-speed traders. High-speed traders is basically legalized fraud. Essentially what happens is they sit close to the stock market, they learn of a movement in a stock at sub-millisecond phrase, they put bids in before everyone else, and they do this really, really quickly. And I was with them. I was not supporting them. I was in an adversarial setting with them. And we were sort of talking, well, we're going to use AI, and it's going to make we're going to be so good at this. And I said, okay, let's do that. Let me have access to your model for 10 minutes. I'm going to bankrupt you in 2 seconds. Right? If I can talk to a model, I can learn everything I need to know about it. And it actually doesn't take all that much effort.
Tech logos.
And there's some consequences here. I sort of talked about the trading, some consequences, right? What if people can perform a constancy of your model? You have student data in a model, and someone can talk to it. And they can learn about your students. There's problems in verbal problems, right? There's a lot of compliance issues related to exposing AI. There's intellectual property. If your business or your research is based on the models that you're creating, and someone else can talk to your model, they can duplicate your model and they can duplicate your research. And so protecting the models is every bit as important as protecting the data and also protecting access to the models. So as you, as an IT organization, begin to think about, hey, we're going to start deploying models. If you're in chemistry, hey, we're going to have this great chemical engineering or chemistry model that all the faculty are going to use. You better be real careful about who you have allowed access to this. This is the keys to the intellectual kingdom. And then finally, privacy. I talked about medical records, right? I don't like medical records really to anybody, right? Do you? No. The students? No. Right? So as our data is leaked, sometimes things are well, sometimes without our knowing, we are being exposed to privacy invasions more and more and more as an AI just sort of hides the realities.
Movie ratings.
But there's some other challenges we're facing in AI. One of the problems is called data curation. So if you're training a model, you've got a lot of data, you need to know what data is good, bad, and different. And we don't really have good science for that. How do you retire data out of a training set to know it's no longer used? For example, if we're using AI for looking at student attention in the room, their behaviors are going to change throughout the day. But on a large scale, the behaviors will change over generations, and that original data might not actually use. And so there's like very fundamental questions about the viability of the data that we're actually providing.
Brief history of fairness bar graph.
AI reproduces bias. I'm going to talk about that in a minute. Fairness. Fairness is just the property of AI that says I'm going to treat one community the same as another. We see this with things like facial recognition. If you're white, it's pretty good. If you're African American, not so good.
Machine learning cartoon.
And that's probably a trending issue, but it's also probably a fine-tuning issue and a bunch of other issues. And so there's a lot of science that needs to happen. And then finally, understandability. So I spent a lot of time in rooms with no windows. I'm sure some of you know what I mean. This is 3 other agencies and myself. And in the room, we're talking about autonomous weapons. So autonomous weapon, we're talking about a Black Hawk. So a Black Hawk, big scary helicopter, perhaps one of the most devastating devices ever to be used in kinetic war. It's a helicopter that has something like what's called a Vulcan on the front of the which is a cannon gun loaded like something like 2,000 rounds per minute. It basically means they can liquefy a human in milliseconds. So the number one problem in the military, and it's been the same problem that has existed since they invented bows, and that is the friend or foe decision. So, particularly in contested areas, so this was a really big problem in Iraq, is that you would have a helicopter that would fly and would turn a corner, and there'd be 3 guys in the corner. One has to surface airness, and you got to make a decision in less, a couple hundred milliseconds on whether that is a friend or foe. If you make the wrong decision, decide it is a foe, and you have just killed 3 American soldiers. If you make the decision that they're a friend and they actually are a foe, you just killed everybody like Black Hawk. This is one of the most devastating decisions they make, and this is something that people actually get trained on in the military. And it's really, really important. And so we were talking about, hey, if we used AI, would we be able to be much more accurate in that decision making? And there were people in the room, and of course, there were some industrial folks who were trying to sell product and said, oh, no, we can get it at 99.9%. And this colonel, his name is Brian Rivera, who's spent a bunch of time in theory. He just stood up and said, no, absolutely not. And they said, well, why? You don't trust the technology? He said, no. Every time someone dies in my company, I have to write their mom a letter describing what happened. I cannot write somebody's mom and tell them the algorithm got it wrong. And it was in that moment I was really sort of struck by that. There are some decisions which are so important that we cannot defer our responsibility as humans to AI, even because it's an icky problem or it's a hard decision that if you make the wrong one, it's real consequences. There's just something about the human experience. There are things that we have to own. And there's going to be tremendous pressure. And I'll talk about that in some of those big areas.
Diagram.
I think you've all heard this. LLMs are they hallucinate. They're wrong. Sometimes they feel like they're being used against us. But for this case, I really want to jump to some misconceptions here. So there's this guy, Charles Goodhart, possibly the most British man that ever lived. He's one of the founding economic theorists of all time. He wrote something called Goodhart's Law. So put shortly, Goodhart's Law says that as soon as you create a metric, say proxy for some outcome, that it suddenly becomes a bad outcome. Miles per gallon is a great example of that. Miles per gallon is not a good measure of the economic, of the environmental impact of a car. Not because having better gas mileage is necessarily a bad thing, but it ignores all of the other factors. Tires are terrible. They're basically crayons. They're just spreading rubber dust all over the world. And increasingly, cars are made of heavy metals. The paint, while we don't get rust the way we used to in the Midwest, in the 1970s and 80s, the paint itself can be highly toxic for the environment to create. So all of these other processes, all of these other things are make this miles per gallon thing sort of irrelevant. But it happened in the 1970s, and everybody, yay, hooray. We still use it, 50 odd years later, because it gives the car companies kind of a free out. Hey, look at my gas mile, right? And there's some good examples where this has been completely used. So why do I bring this up? I bring this up, we're going to see the same thing with AI. So suppose Harvard's in a lot of trouble and we're making fun of Harvard. So, they're in a lot of trouble because their admissions practices are deeply unfair, particularly to people who are Asian. And so they've been sued a couple of times. And I was in a meeting with some of the admissions people, and they were sort of discussing a number of options, and AI came up, and there was a discussion around this. And they said, well, why don't we just use it? I said, well, no. That's not actually going to work. First of all, if you train the admissions on old data, what are you going to get? You're going to get the same bias. And I said, oh, well, we're going to get the best people in the world, we're going to clean up the data, and we'll remove all of that unfairness. And I said, no. Even if you were able to do that, and I don't think you can, even if you did that, the model itself will now become the target. So when you apply to Harvard, you will be judged on how that model feels about you. And people will not target being a good applicant to Harvard. They'll figure out what makes Harvard application happen. So anybody guesses on what that would be? What would make a Harvard model happen?
Good heart photo.
All right. What would make a Harvard model happen? To get admission.
From HBM.
All right. That's a joke. IGPA, you would think it's IGPA, thanks for stepping on it. And think the high GPA or something like that. Actually, it would be something like varsity tests. Why? Rich, Northeast, high schools. Connecticut, Massachusetts, rich kids from rich high schools. It doesn't really matter. People will, when you put a model there, for any human endeavor, people will figure out how to make a model happy, not how to be a good person who's applying for something. That's just economic theory. People will take the easiest path. And it's unavoidable.
AI rejection fallacy.
So in the last few minutes, I want to talk about a couple of basic fallacies before we get into what's going to happen with this. First one is, I just spent some time in Silicon Valley and I wanted to hurt myself. First of all, if I hear a gent one more time, I'm going to throw myself off the top of the mortgage wall. But there was constant conversation. Oh, people are rejecting AI because they don't get it, or they're scared, or they're neophytes. And I said, no. People are rejecting AI because they don't trust it. There have been at least 3 to 4 major technological evolutions in my time on this planet. And each one, big tech has somehow screwed the pockets. Remember search? Remember first time you pulled up Google for those of us old enough? Well, pretended. Right? It was like, it's a brand new world. This little Aladdin thing going on. It's fine. You know what it is now? It's arbitrage. When you go to Google and you put in query, they don't even bother looking for the best thing. They say, who will pay the most? Those are the links you get. And if you think that non-sponsored is somehow better, you're absolutely wrong. Your whole experience on the web is now controlled by money. And I bring this up because this is that's a whole other problem. That's a big problem. But because the same thing is happening with AI. No one trusts it, right? If you went to OpenAI and you said, here, I'm going to give you $1 billion so that every single time somebody asks for University Computer Science Department, Wisconsin, would they take it? Would they even think about it? Would they take a pause? Oh, hell no. Right? And this is one of the problems, is that they haven't actually figured out how to monetize it. Anthropic and OpenAI are hemorrhaging. They're going to want that money back sometime. Do you think your queries are not going to get sold? I'm talking to a pretty shady room, so right. They're going to need those investors want their money back somehow. What are we going to do? I don't know. But I think there's a fundamental misdiagnosis. And it's also not really shown a lot of that. Honestly. I mean, the text thing is cool. The coding thing is kind of cool, although we may be heading in the wrong direction. But people don't trust AI. How many people trust AI? All right, good. Run right in.
I and human capital fallacy.
This one affects you. Affects me. Judy Faulkner, anybody do this? Right? Founder of it. She had this, she talked upstairs a couple months ago, and she said something that really struck me. She said, people underestimate the complexity of the human existence. Right? She's not wrong a lot. I started thinking about that and some other things that I read. And then I went and I started reading a bunch of economic theory. I actually read about things like blacksmiths during the Industrial Revolution. Most recently, I think the most obvious example would be spreadsheets. So when spreadsheets came out, originally late 70s, they really saw broad adoption in the mid-80s, early to mid-80s. And suddenly, everyone said, do not get an accounting degree. No one's going to need accounting.
Fallacy. AI will expand tech workforce.
What? Now, it turns out there's an economic theory. It's time and time again throughout history, it's been true. Is that at every one of these major changes, we don't need less of those people, we need more. So just for those of you who are in the IT business, thanks everybody. What's going to happen? Your workload is going to increase by at least 1/3. Because you're going to be managing IT. We need more, not less. You are absolutely elite. Economic theory says people that are promoting this don't get a CS degree. Well, what do you think's going to drive all this AI, right? It doesn't, and it's just economic theory, right? I'll give you a great example. Oracle. You've ever heard about Oracle firing 30,000 people because of AI? What's the bad guy? We're out of money. They aren't needing an excuse to fire 30,000 people. Don't buy it. Don't buy it. We are going to be, AI doesn't operate in the past. And I hope everything I've shown you today has helped you understand that. AI is not something you just let loose. It's wrong, it's exploitable. It's dealing with non-stationary phenomena. All of these things mean that AI needs us more, not less.
Text. Next. Generalized artificial intelligence, GAI.
Okay. Generalized AI. So what does it actually mean? Right? I think that generalized AI, and we could argue, what it actually means, or, 2027, I've heard it all.
GAI extinction event.
And it's like really a soap opera. Okay, so it's the next generation of the model that can reason, have a little bit more memory. Fine. A bunch of people got together. These are very serious people. Him and Vizio are some people got some notorious for their work on AI. So I'm not diminishing these people and a bunch of CEOs. And they wrote this doomsday report in 2023, that was talking about killer robots. I said killer robots, they didn't talk about killer robots. That's just sort of the way I think about this report. It was just sort of this doomsday, once we have generalized AI, the world is doomed and it's going to take over, and blah, 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 blah. And it struck me that there's way too much, there seems to be like two extremes here. AI is nirvana, or AI is the end of existence. And all of that, I feel, and this is me, not University of Wisconsin talking, and definitely not College of AI, is that I feel like these are the discussions that you have when you don't want to have the kitchen table discussions about AI.
The box lists some signatories of the letter.
This is the wrong conversation to be had. This avoids all the messy stuff about how we structure some jobs and our economy. It's a great way to distract people from AI being used to exploit them. We are at a university. I am a state employee. I work for the people of Wisconsin. And it is my job to help them understand AI. It's my job to help people on 20 blocks from here, the State House, understand what the implications of AI are. So when we get into these long, protracted discussions about doomsday viruses and things like that, sure, fine. That just completely ignores how this is actually impacting us. I have not really seen a cogent public policy around AI or a discussion. Interestingly enough, I had a great moment. And it gave me great faith in the next generation. And particularly University of Wisconsin students who are crazy good. So they self-organized an event. It was in this room about the ethics of AI. And they invited me to come here to talk this, I do the clown show. And I came in and I expected to see, 30 people, tops. There's 250 people and they were engaged. I think the younger generation has some kind of defensive posture against AI. For the first time in my history, I've seen a generation go, yeah, now you don't get to do it to us again. So it gives me great faith. It gives me great hope.
Red X appear over the extinction event slide.
So, not something to worry about right now.
Text. Concluding remarks.
So what's going to happen to you guys? Or us?
Text. What are the major impacts on IT at UW?
Well, as I said, your job's about to get harder. There's going to be more stuff. The velocity of the stuff is increasing. The needs of your faculty are changing. Their students are getting staff are going to change very fast. The competitive landscape of academic research, I'm going to just deep research on this, basically on that, is going to change. Some universities are going to have the organizations, not many universities have the organization, the IT history that Wisconsin or the ball is. Wisconsin does not have a lot of universities. And I'm not just pampering, that's just the God's honest truth, is that the job is going to require you to be good stewards of AI and be conscious of this. And recognize faculty and students, staff sometimes make, I know this is going to be a surprise, bad decisions, right? So what I think you really need to be an ear. It's really what I'm doing here today is I'm evangelizing. You have to be activated on this front. Stay informed, stay active. There's an ongoing pursuit right now about how do we create policy for the university around AI, what it means in all of its multiple dimensions. We don't have the answer to that question, but it's really important because your voice, you are the front lines. The resource costs are going to go up. Third parties are going to be necessary. There are just things. You know, one of the conversations, people like Todd and I have been having is like, what are the services we're going to need in the future? Can we run our own big models, or are we going to have to use third parties? I think in the short term and possibly the long term, we're going to need to use large ones. But we have to be judicious use of it, and we have to have some policy around it, and have to be regulated.
Now, where AI is going to affect certified
For you guys.
And so I'll go back to Judy Faulkner
And say, listen, your job is very complicated. And throwing AI at it, everything you do is exceptions, right? Everything you do is exceptions, and there are things that are in your head, or in the PI's head, or the student's head, or the staff's head that the AI is not going to be aware of. There are going to be constraints and requirements. They're going to be like, no, it's Friday of finals. We do not turn off, this service because no one will be able to submit their homework or their final projects, right? These are the kinds of things AI will, not really be able to anticipate. And that's the human endeavor. And so much of what you guys do is actually a social activity, right? It's a negotiation, it's a conversation about what people need and what's important. AI will not replace that. It will replace a lot of mundane things. I think we're using it, Nick, in CAI. It's not CAI. Please don't let that catch on. CAI. And also not CIA, that's something else. So we're using AI for some very simple kinds of data processing things. And I think all of you at one time have sort of experience with some AI pipelines, which are really helpful. And that's really what's going to happen. I think for you, the tooling will get better. The grokking, Splunk logs, that sort of thing is going to get better. Those are going to increase. You're going to be able to have better debugging tools. But it will not replace. It will not replace your judgment or your expertise or your institutional knowledge or your agility. And when it comes to some AI, you guys achieve, right? The reality is that economics of AI are not clear at all. And the last thing is that you will now have to add another club to your bag or arrow to your quiver or whatever metaphor you want to use, is that you will have to know these tools. You will have to learn to apply these tools. You'll have to learn to tune them and debug them. And there's going to be a lot of economic pressure to do this. And there's going to be, you guys in IT, there's a lot of impatience and a lot of anger management issues amongst people with staff and faculty, right? And so it's just going to be like this whole retraining process for you guys. I'm going through it every day. I can't keep up. I sort of give up trying, but I try to keep up on some things. Tooling is one, But I think that's going to be the big change for you.
CAI Department's diagram.
So last, I just wanted to say, just in a couple seconds,
I want to say thank you, and I want to welcome you to CAI. Welcome to this building. I will take a moment to recognize Nick and the entire CS organization.
The diagram has centers and institutes, plus departments under the CAI heading.
The astonishing story. We were moved from the world's worst building to the world's best, and the building is still there. Not for me, it isn't. I'm not walking in that, I'd step foot in that. No, but Nick and his team in 10 days moved 3 departments from, 2 from there and 1 from over by, from the high school, from over by the city union, and 2 from the building across the street in 10 days. And I swear to God, I did not hear a single complaint. Not a single complaint from anyone. It was simply astonishing. And so to Nick and his team, thank you so much. The launch of CI was made possible by you guys. So thanks again.
Departments: computer sciences, statistics and data science, iSchool, etc.
Well, that's it. I know. That's right. You can't show me how. So what is CA? This is the big question, right? So, CAI is the recognition, the history of computing is that a long time ago it was sort of math. In the 80s, it moved from math to engineering, late 80s, early 90s. It didn't fit in math. It kind of stayed in LNS because Wisconsin's Wisconsin, and no one knows. But at every place, we never fit. And so people started in colleges and computing, but at this moment, we became, 3 programs which are top 12 in the world. We have a nexus here. We are going to have 50 faculty and $100 million. We, with your help, are simply going to change the center of gravity in technology in the United States. And so CI will serve that purpose, hopefully well. So thank you.
QR code in top right.
We ran right up onto time here, so unfortunately we will not have time for Q&A for this session, but please, let's thank again Professor McDaniel.
Text: McDaniel at cs.wisc.edu, patrickmcdaniel.org.